Assalamu alaikum. This is chemistry 12th, and our today's lecture is about the properties of these carboxylic acids. And in our we have discussed the preparation of these carboxylic acids in our previous lecture. Now in this lecture we are going to discuss the properties of these carboxylic acids. Now as far as the properties of these carboxylic acids are concerned, we have got physical properties and we have got chemical properties. Now as far as the physical properties of these carboxylic acids are concerned, the first is their physical state. Now as far as the physical state of these carboxylic acids is concerned, the first three members of the carboxylic acids, they are colorless liquids and have got a pungent smell, and the next six members are their oily liquids with an unpleasant odor. And thereafter, that means the carbon atoms, and that means the carboxylic acids which have got carbon atoms more than 9, they are colorless waxy solids. Now as far as benzoic acid is concerned, it benzoic acid and its homologues, they are colorless, these solids. Then we have got another property, that is their solubility. Well, as far as the solubility of these carboxylic acids is concerned, the aliphatic these carboxylic acids, among these aliphatic these carboxylic acids, the first four members are very soluble. They are soluble in water, and the solubility decreases gradually with their rise in the molecular mass. However, all these carboxylic acids, they are soluble in organic solvents like alcohol, ether, benzene, etc. As far as benzoic acid is concerned, benzoic acid, it is sparingly soluble in cool water but soluble in hot water, alcohol, ether, etc. Now this solubility of the lower members of these carboxylic acids, it is due to the formation of hydrogen bonds, or it is due to hydrogen bonding, in which we see the carboxylic oxygen, and the carboxylic oxygen forms hydrogen bonds with the hydrogen atom of the waters, and hydroxyl atom of the hydroxyl group, it forms hydrogen bonds with the oxygen atom of the water molecule. As you can see here, this is water molecule and this is carboxylic acid. Now we see the oxygen atom of this water molecule, this is involved in the hydrogen bonding with the hydrogen of the hydroxyl group of this carboxylic acid. Similarly, this oxygen of this carboxylic group of this carboxylic acid, it is involved in hydrogen bonding with the hydrogen atom of the water molecule. This leads to molecular association, and obviously the melting point is the solubility gets increased. This is due to the formation of hydrogen bonding. Now the solubility of these carboxylic acids, we see it gradually decreases with the increase in size of the alkyl group, and or it increases, as I have told you that this solubility decreases with increase in the size of the alkyl group or the molecular mass. This is due to the reduced polarity, or it is due to the hindrance provided by the large this alkyl groups to the carboxylic group which takes part in the hydrogen bonding. Now then we have got the boiling point. This is the another physical property. It was the solubility. Now the boiling points of these, as far as the boiling points of these carboxylic acids are concerned, carboxylic acids have got higher boiling points due to the presence of due to the presence of this intramolecular hydrogen bonding. As a result of hydrogen bonding, they exist as dimers, and these have got a higher boiling points than the corresponding alcohols of comparable molecular masses. You can see here, you can see we have got ethanoic acid, we have got here propanol, then we have got this is butane, normal butane. Although they are comparable masses, we see and that the boiling point of this is ethanoic acid, it is 390 Kelvin. Then we see the boiling point of this is N-propanol, it is 370 Kelvin. And then we have got the boiling point of this butane, it is and this is N-butane, it is 309 Kelvin. Now the higher boiling points of these carboxylic acids compared to alcohol is due to two main reasons. One of the reason is that as compared to alcohols, we see the OH bond in carboxylic acids, it is more it is more polar, or it is strongly polarized due to the presence of the adjacent electron withdrawing carbonyl group, because this carbonyl group, it is acts as an electron withdrawing group. Therefore carboxylic acids can form stronger hydrogen bonds. On the other hand, this is one factor. Second factor is that the molecules of these carboxylic acids, they are held together by, we see two molecules of these carboxylic acids, they are held together by two hydrogen bonds, and therefore they exist as a dimers. Now you can see this is how this hydrogen bonding takes place in this, this is alcohol molecule, how they get this is intermolecular this hydrogen bonding here. Here you see, here it is intramolecule this hydrogen bonding taking place between the two carboxylic acid molecules. Now the carboxylic acid molecules are held together by strong attractive forces, and therefore high they have got higher boiling points. Now the existence of this dimer, or the cyclic dimers of the carboxylic acid, is supported by the fact that the observed molecular mass in the solvents are quite higher, almost it is double than the actual value. For example, the molecular mass of acetic acid in benzene, as it is determined by the colligative properties, like we have got elevation in boiling point, we have got diffraction in freezing point, osmotic pressure, etc. It has been calculated as it is 120 instead of 60. This is due to dimerization. So this shows that these acid molecules, this acid, that is acetic acid, it acts as a dimer in benzene. Now among the monocarboxylic acids, that means those carboxylic acids which have got one carboxylic group, the boiling points increase with the increase in the molecular mass. As the size of the this alkyl group increases, the magnitude of these attractive forces, that is van der Waals forces, they also get increased. And once these attractive forces get increased, the boiling points, they also get increased. For example, you can see this is here this methanoic acid, it has got this boiling point of 300, this is 73 Kelvin. Then we have got ethanoic acid, its boiling point is 391 Kelvin. Then we have got this propanoic acid, its boiling point is 424. Then we have got this is butanoic acid with 4 carbon atoms, its boiling point is 434 Kelvin. Now as far as the melting points are concerned, the melting points of these carboxylic acids are concerned, the melting points they increase irregularly with the increase of the molecular mass. And it has been observed that the first 10 members, in the first 10 members of these carboxylic acids, the melting points of the carboxylic acids which contain even number of these carbon atoms, they are higher than those members which have got odd number of carbon atoms. For example, you can see here, this I have shown here, this is the and this I have shown, I can show you here. This is the melting point. Yes, this is the melting point. It has got a 1 2 3. There are 3 carbon atoms in this case. This melting point is 251. Then we have got this is butanoic acid. It has got these 4 carbon atoms, and its melting point is for 267. Then we have got this is a 5 carbon acid, and it is pentanoic acid, 1 2 3 4 5, and it is this melting point is 237. Now we see that these carboxylic acids which have got odd number of these carbon atoms, they have got low melting points as compared to the acids which have got even number of and the even number of these carbon atoms. There is a reason behind it, and it has been shown by X-ray diffraction methods that the acids with even number of carbon atoms, they have got carboxylic group and the terminal methyl group on the opposite sides of the chain, that is zigzag chain. As in a zigzag chain. As a result of this as a result of this, it leads to close packing of its molecules in the crystal lattice. As a result of which the attractive forces or intermolecular forces, they become stronger. On the other hand, we see that acids with odd number of these carbon atoms, they have got the carboxylic group, and they have got the carboxylic group and the terminal methyl group. They are on the same side of the zigzag chain. Therefore, this leads to this leads to poor packing of its molecules in the crystal lattice, and hence weaker intermolecular forces exist. So this is because of strong intermolecular forces that the melting points of the carboxylic acids with even number of these carbon atoms, they are higher than those which have got odd number of carbon atoms. As you can see here, this is a carboxylic acid molecule which has got this even number of these carbon atoms. We see that the carboxylic group and terminal methyl group, they are on the opposite sides, while as this one which has got five carbon atoms, and we see the carboxylic group and the terminal methyl group, they are on the same side of this zigzag chain. Now however, this trend is noticed only in members which have got in the members of this homologous series up to 10 carbon atoms. In higher members, we see the melting point is generally increase with the increase in the molecular mass. However, we see the melting points and the boiling points of these aromatic acids, they are usually they are higher than those of aliphatic acids of comparable masses. This is probably due to the fact that benzene has got a planar structure, and which leads to close packing of its molecule in the crystal lattice as compared to the zigzag structure of the aliphatic acid. So this is about the physical properties of these carboxylic acids, that is their physical state. Then we have the solubility, boiling points, and melting points. And this is for today. In our next lecture we will discuss their chemical properties. This is for today. Thank you.